So this video is we're still talking about vertical motion, but it's just a slightly different context than what we were viewing yesterday and the day before, but the same general idea. So it says vertical motion can be modeled by the formula d equals rt minus 5t squared, where r is the initial upward velocity, so that's important. R is the velocity, t is the time, and d is the height of the object. Use the formula to model the situation given. So this is talking about a rock being thrown off a cliff. So it says, suppose that you throw a rock into the air from the top of a cliff with an initial velocity of 40 meters per second. So find a particular equation that models this situation. All right, so what it's saying is referencing this right here, create your equation knowing that the initial velocity is 40 meters per second. So I'm just going to write down the distance or the height the rock flies is equal to 40, right, because that's meters per second, and meters per second for the rate, t minus 5t squared. And this is going to be the equation we're using to answer all of the following questions. So I'm going to zoom in a little bit. All right, so it says, sketch a graph of this situation with appropriate window. All right, well, I mean, in order to do that, you need to answer a few questions, and typically I would just tell people to start off by finding that vertex. It's always the same, guys. Everything is based on the vertex, because we know that the vertex is either, if it's a quadratic facing downward, concave down, it's either the maximum. If it's concave up, it's the minimum. So everything about the window is based on that vertex. I mean, a lot of it, pretty much. So I'm going to start off finding the vertex. So remember, it's negative b over 2a to find the x value of the vertex. So negative b divided by 2a. So that equals, negative b is negative 40 divided by 2 times a. 2 times a is negative 10. So my vertex is positive 4. Okay. So it's positive 4. Now I'm going to find out the y value that goes along with that vertex. So positive 4, comma what? So in 4 seconds, how high is this thing? So I'm going to plug 4 back into this equation right here. So 4 times 40, I know that's 160. Then minus 5 times 4 squared. So 4 squared is 16. 16 times 5, I think that is, let's see, 80. So minus 80. So it's a height of 80 feet. Okay, so now with that, I can pretty well shape my window. Let's see. It doesn't say, the thing is it's from a cliff, so it's gonna make this a little funny, but I'll explain that later. Here's what your window should look like. And usually I go a few feet or seconds outside of the window, but here's the idea. If that's your vertex, and it took 4 seconds to get there, that means from the top, so imagine here, it takes 4 seconds to get there, it's going to take 4 seconds to come back down and hit the same level you threw it from. So my x minimum is going to go anywhere from 0, there's the middle, to the maximum of 8. All right, my y minimum is going to go anywhere from 0 to a maximum of 80. So I'll say 90, just to go just a little bit above that. And then the scale, I usually don't even worry about this. So I mean, you could go by 10s, you can go by 5s, however you want to do that. For the x scale, I'd probably go by 1s just because it goes all the way up to 8. But y scale goes up to 90. I'd maybe go by 5s or 10s. I'm not really going to worry about this right now. Okay. So now I'm going to go ahead and graph this. So graph, let's see. There we go. It's going a little bit slow. I want to clear this out, whatever we got going on here. All right. There we go. All right. Menu, I'm going to go to window, a standard setting. Okay. Now I'm going to type this in. So I've got 40x minus 5x squared. And sure enough, it does go up at 0, and you can see that. And so look at my scale that I even told, or I foretold, I guess, that I would use. It goes from 0 to 8, and you can see the quadratic's going up from 0, and it's coming down at 8. All right, but I'm going to use that scale, or that window now, and actually change the settings on this calculator. So I don't want to see anything but from 0 to 8. And then the Y minimum, I want to go from 0 to 90. And remember, 90 is about 10 feet above the max height of this rock flying. But now we got a really good view of our quadratic to answer questions with. All right, so I'm going to zoom back out real quick. So it says, sketch a graph of this situation with appropriate window. All right, well, I'm going to do something like what I see here. So, and it's just a sketch, so it's an estimation. Something like that, where that's 8 seconds, vertex is at 4 seconds, the maximum height is 80. Okay, that's fine. Determine a reasonable domain and range that represents the situation. Well, it's actually what we're talking about. Now remember, domain, that's talking about the inputs or the x values. So a reasonable domain is anywhere from 0 to 8 seconds while this is in the air. For now, that'll work. Reasonable. Okay, it's not exact, it's reasonable. So anywhere from 0, and I'm going to put a bracket because I'm actually holding the rock in my hand at 0 seconds. Okay, to 8 seconds when it hits the ground. Okay, 0 to 8 seconds. A range can go anywhere from 0 to a height of 80 feet. 0 to 80 feet. How high will the rock be above the cliff after 2 seconds? Well, that's, again, a question for the calculator, so I'm going to go ahead and zoom in. And I talked about this on yesterday's video, so I'm not going to explain it much. What I'm going to do is, going to go to Menu, Trace, which is 5, and then 1, Graph Trace. And then at 2 seconds, I'm going to type in 2, it's 60 feet high. Okay, and then at 4 seconds, I'm going to type in 4, it's 80 feet high. So it says, how high will the rock be? How high will the rock be above the cliff after 2 seconds? 60 feet. And then how high will it be after 4 seconds? 80 feet. Okay. When will it again be at the same level you threw it from? Okay, well remember we're standing on the cliff. So we already can answer this question. So right here is where I threw it from. 0 is where I threw it from. And it hits 8 seconds later. So remember, it reaches its peak at 4 seconds. It hits at 8 seconds. All right. When will it hit the water 100 meters below where you threw it? So in other words, the cliff is 100 meters high. The cliff's 100 meters high. When will it hit the water 100 meters below the cliff? So if you are imagining this correctly, let's see, I'm going to change my window real quick just so we can see a little bit better. I'm going to go from 0 to, let's say, 10, 0, oh no, I want to go from a minimum of negative 200 to positive 100. All right, this graph is going to look a lot smaller now that I've changed this window. I'll zoom in real quick. So the question was, when is it going to hit 100 meters below the cliff? All right, here's the cliff. That's where I threw it from, okay? 4 seconds later, it's 80 feet up in the air. 8 seconds later, it's back at the same height that I threw it from. So if I want to find 100 meters below where I threw it from, then that's going to be down here somewhere, okay? So I'm going to create, actually, a line that's at negative 100. And the intersection of my parabola and that line, that's going to be when it hits 100 feet below where I threw it from. Okay, so I'm going to do menu, analyze graph. I'm looking for the intersection. Click here, click here. So at 10 seconds, it's going to be 100 feet or 100 meters below. So when will it hit the water? Sorry, let me zoom out again. This zooming in and zooming out is kind of catching me. But when will it hit the water? 100 meters below where I threw it from? 10 seconds after being thrown. So again, what we're doing here is the same type of questions that we were doing yesterday and the day before, except slightly different format to them. Okay, slightly different type of question. I mean, they're still vertical motion. They're still all vertical motion questions, but the way that the questions are asked are a little bit different. Also, you can clearly see that I should have been probably using meters instead of feet. I'm just in such a habit of using feet. I should have probably been using meters, so that should have been probably 60 meters, 80 meters. Okay. Anyway, guys, I'll explain it once more in class, but if you're not here, here's a video that should help you, and also if you're a little confused, I hope this video helped as well. I'll see you guys in class.